What exactly is an electric dipole? An electric dipole consists of two electric charges separated by a very small distance L. For this system, we define a quantity called the dipole moment, given by P equals Q dot L. But how do we actually calculate the electric field of a dipole? Now consider the dipole shown in this figure. Imagine that we are standing at the observation point, just below the negative charge, and we want to calculate the electric field of the dipole at a point located a distance r away. Notice that this represents the most general configuration for calculating the electric field of a dipole. To proceed, we draw the necessary vectors, as shown in the diagram. For the configuration we just described, the electric field can be written as follows. To obtain a usable expression for the dipole field, we expand the denominator of the first term using Newton's binomial expansion. Now we substitute the result of the expansion back into the first fraction and carry out the necessary algebra. Two terms with equal magnitude but opposite signs appear, the first and the second terms, and they cancel each other out. For clarity and convention, we rearrange the remaining terms by swapping the negative and positive terms. Recall that the electric dipole moment is defined as P equals Q times L. So by factoring out Q from the bracket, the terms Q times L can be replaced with P. The result is the expression for the electric field of a dipole in its most general form.